I mentioned that both repeatability and within lab long-term reproducibility can be evaluated with pooled standard deviation. And let us see now how to set such experiments up in practice. Let us look now how the experimental logic will look like if we want to estimate repeatability from pooled standard deviation. And I will explain this with a graph. On one axis of the graph, we will have samples. And on the other axis, we have days. And suppose we have 4 different samples. 1, 2, 3, 4. And now, since with each of the sample for correct repeatability estimation, we have to carry out the full analytical procedure, including also the sample preparation, then we cannot make many measurements within a single day. But suppose on day 1, we work with sample number 1 and we make altogether 4 measurements with it. 1, 2, 3, 4. On day 2, we work with sample number 3 and we make 3 measurements with it. Let me also mark the days here. On day 3, we will work with sample number 2 and we will make 5 measurements. And finally, on day 4, we will work with sample number 4 and we will make 2 measurements. So, from each of these sets of measurements, we can calculate repeatability for this particular sample on this particular day. Of course, obviously, these days do not need to be consecutive days. They can be far apart from each other, separated by several weeks. And now, in this particular case, N1 will be 4, N2 will be 5, N3 will be 3, and N4 will be 2. And if we add all these numbers up, we will get 4 plus 5 equal to 9, plus 3 equal to 12, plus 2 equal to 14. And if we subtract from this the number of samples, which is 4, we get 10, which will be for us the number of degrees of freedom. Meaning the pooled standard deviation calculated by this approach corresponds to the situation as if we had made 11 measurements within a single day on one single sample. But as I explained previously, this approach in fact gives you a more reliable repeatability estimate because different samples are involved, which can be slightly different by their matrix or by the difficulty of analysis, and also different days are involved, meaning the laboratory settings can be slightly different. Let us look now at the practical calculation of pooled standard deviation on the example of determination of an antibiotic, meropenem, in blood plasma by HPLC. And here are the data which exactly correspond to the situation which I just showed on the whiteboard. So different days, different samples, and different numbers of parallel measurements. And I have also incorporated here into the slides the formula by which the pooled standard deviation is calculated. And we will first start by calculating the standard deviations for all the samples and also by writing the numbers of n-1 for all the samples. So standard deviation expressed in micrograms per gram. And I will mark the area in such a way that it would be suitable for each and every of these columns. Those empty cells will be omitted by the stdev function, so they will not be considered by as zeros, so the calculations will be correct. So these are now the individual standard deviations. Now it's useful to write here the n-1 values. In this case it's 3, in this case it's 2, in this case it's 4, in this case it's 1. And now it's useful to make a row where the n-1 is multiplied by the standard deviation squared. n-1 multiplied by s squared. So, and now we have all the data needed for calculating the pooled standard deviation. And let me just comment on the denominator of this ratio here. If we sum up n-1, n1, n2, etc. and subtract then the k, then in fact this will be exactly the same as the sum of the n-1 values. And since we have the n-1 values nicely available here, we will in fact instead of this use the sum of n-1 values for the calculation. So it's a repeatability pooled standard deviation and is equal to square root, and it now is a ratio of two sums, sum of these products here divided by the sum of all the n-1 values here. And of course it is expressed the same way in micrograms per gram. So if we want to characterize this procedure by repeatability estimate, then this repeatability estimate would be most suitable because it has been determined with different samples on different days. And it is important to mention that even though the days are different, since on each day we have the standard deviation which gives us repeatability because all the measurements were done on the same day, then all these are repeatability standard deviations. And when we pool repeatability standard deviation, we also get repeatability standard deviation. So even though the experiments were carried out on different days, we do not get reproducibility, but we get repeatability standard deviation.